Measurement lesson is all about rounding and substitution. So this should be a review. I'm just going to skip right to class example 1 on page 114, which is how to do rounding. So if you are asked to round to the nearest 1, that's the same as asking them to round to the nearest whole number. So the nearest whole number would be here, which is 8. But you have to look at the neighbor, the one to the right, and see if it's higher, greater or equal to 5, then it's actually going to go up by 1. So rounded to the nearest 1, this is going to be 539. To the nearest 10, again, we need to look at the 10 spot and ask, does it go up by 1? And it does because its neighbor is 8, so this would round to 540. To the nearest 100 would be about 500, and because the next digit is a 3, it does not round up, it just rounds to 500. The nearest tenth, do not confuse that with the nearest 10. The nearest tenth is the first decimal place here. So it would be 5, but because of the 9, it'll round up. 538.6. To the nearest hundredth is 2 decimal places. So it would be the 5 and the 9. We want to keep both, but because the next digit is the 6, the 9 has to round up. So how are you supposed to round up 9? Well, it will round up to 10, and that 10 spot will cause the 5 to bump up by 1. So we're looking at 538.60. You have to put the 0 because if they ask for it to the nearest 100, they're expecting to see 2 decimal places. So you have to write both of them if this rounds up. The 0 does matter. So the first decimal place is the exact same as the nearest tenth, 538.6, and the second decimal place is the same as the hundredth, 538.60. So in this example here, to the nearest 1, we're looking at 4, but it does round up. 965, nearest 10, the 6 does not round up. 960, the nearest 100, this one here, and it does round up. So we're going to have 11,000. The 10th, this one here, and it does round up. So 10964.9. 100th, 2 decimal places over here, and this 9 does not round up. So we're going to just keep it. And this would be the same as this, and this one is the same as that. You do not need to know how to use a graphing calculator to round. You can do it in your head. So if you're interested, it's here, but it's not expected that you know how to do that. It's often going to be much, much faster just doing it in your head. Rounding in scientific notation. We are not doing scientific notation in this course, so you will not be tested on it, but it is relevant if you are doing science, especially physics. So I'm not going to cover that right here. But this is important. Substitution in algebraic expressions. Class example number 5. So you should know this from Math 15. It's easy to understand, but a lot of things can go wrong. The key here is always use brackets when you're substituting. So if I am trying to substitute for y, I need to put -3 in brackets and then square, minus 7, x is 2, minus 3. So they've told us what x and y are. The reason it's so important to put this in brackets is because that will change the effect of the squared. Is this 9 or is it -9? Well, if -3 is in brackets, as it should be, it will end up squaring the negative and you're going to get +9. So 9 minus 14 minus 3 is -8. And over here, we need to make sure we put this in brackets. Minus -3 plus -3 cubed. So notice all my substitutions are in brackets. So this will be 9 times 4. These are 2 negatives, one from the expression, one from the -3. So they cancel out to make +3, and this is -27. Remember, if you cube a negative, it is still negative. So 9 times 4 is 36, plus 3 minus 27 is +12. There are ways to substitute using a graphing calculator. I have personally never done it because I haven't found it to be necessary. You can always just type it in if you are good with the brackets. Class example 6 says use a graphing calculator to find the value of this expression. I do not expect you to use a graphing calculator. I would expect that you are plugging it in by hand. So 2 times a, which is -2, plus 4 times v minus a squared, so -2 squared, and we put it in brackets, plus negative 3 squared. So just be careful as to what happens to all the signs. So this is still negative 4. This is negative 12. This minus lives, but that minus dies, because if you square negative, it's positive again. And that negative dies as well. So we're looking at negative 4 minus 12 minus 4 plus 9, which is negative 11. Class example 7 asks us to substitute first and then calculate the indicated variable. That's not my preferred way of doing things. I prefer to rearrange first, but they've told us to substitute first. So they're telling us that v is 12. So we'll put in 12 for v, and we're asked to calculate t. So in this case, we just need to divide both sides by 12, and we're going to have t is 5. Over here, s is 100, and they want us to calculate r. So we can divide both sides by 4 pi. And they've asked us to round this to the nearest tenth. The important thing is if you put this in your calculator, you have to put the denominator in brackets. Otherwise, it will divide by 4 and then multiply by pi instead of dividing by 4 pi. So that's a very common mistake. Students lose marks because of that. If you do this correctly, you're going to get 7.9577, but to the nearest tenth, I need to round up 9. So this is actually going to go to 8.0 because 9 rounds up to 10. But I still have to write the 0 because they're expecting to see one decimal place. Over here, v is 95. 4/3 pi r cubed. So the first thing I always like to do in this case is to get rid of the fraction because I don't like dealing with the fractions. So I'll multiply both sides by 3 to kill that off. 3 times 95 is 285. So 285 is equal to 4 pi r cubed. And again, you can divide by 4 pi. Just make sure that when you put this in your calculator that this is in brackets. So r cubed is equal to 285 divided by 4 pi. And to get r by itself, you do need to do a cube root. And this is where your calculator skills are really tested. I think that the best way to do this is to take the 285 and then divide by 4 pi. So if I do that, 285 divide by, in brackets, 4 pi, I'm getting approximately 22.696. Now you can keep 4 decimal places and that'll be pretty good. If you want to cube root that, you can. There's a cube root button here. But I'm going to cube root shift answer on my Casio so that I don't have to type that in again. If you type this in correctly, you are going to get 2.8 as your R value. So this is just calculator skills. If you can type this in one shot, you absolutely can. You just have to make sure your brackets are correct. If you're getting 2.8, you've typed it correctly. If you're getting something else, then you haven't. So in each of the following, solve for the variable indicated and then substitute. So this is my preferred way of doing things, that we isolate first and then we substitute. So in the first example, they're asking us to solve for r and then substitute s as 75. So again, we can multiply both sides by 4 to get rid of that fraction. So 4s is equal to pi r. And then divide both sides by pi to get r by itself. So r is equal to 4s over pi. But then they want us to substitute in 75 for s. So we will do that. So 4 times 75 and then divide by pi is 95.5. In part B, we are solving for r again. So we will divide both sides by pi, like so. A over pi is r squared. And to get rid of the squared, we will square root both sides. So now we have r is equal to the square root of a over pi. And we're going to substitute in. So if you want to type this in your calculator all in one shot, you sure can, but you have to put the inside of the radical in brackets. Make sure you close the brackets correctly. And if you do this correctly, you will get 4.8. Last example, solve for h. So I always like to get rid of the fraction first by multiplying both sides by 3. So 3v is equal to pi r squared h. And then I can divide both sides by pi r squared to get h is equal to 3v over pi r squared. So they've given us v and they've given us r. So we're typing in 3 times 20 and then pi of 9 squared. So I'm going to clean this up a little bit. 3 times 20 is 60, and then 81 pi. Now be careful, when you type this in, you better put the bottom in brackets or you're going to get it wrong. Bracket 81 pi, close the bracket, and I'm getting 0.2 as the value of h.